Hello and welcome to Unit Lesson 8.5 Line Plots with 1/2 of an inch, 1/4 of an inch, and 1/8 of inches. Made by Caitlin and Ethan. Today I want you to solve this math message. Sydney wants to mail a thank you card that is 5 1/2 inches high and 8 1/2 inches long. Would knowing the perimeter of an envelope help Sydney determine whether the card will fit in it? Well, your answer should have been no, because if I want the card to fit, the length and height of the card and envelope are important. The envelope needs to be just a little bit bigger than the card so that the card will fit inside. Knowing the perimeter of the envelope doesn't tell me whether the length and height are both a little bigger than the card. Because if you do not understand that, here, let me just draw, say, this is the card, this is the envelope. It needs to be just a little bit bigger than the envelope needs to be just a little bit bigger than the card, because if they were the same size, they would not fit in each other, since they would just obviously not fit, because, well, these two edges would not fit. So, next explanation that you might have put as one of your answers. Another thing you could have used as your explanation is, knowing the perimeter of an envelope tells me the distance around it, but not the specific length and height. What that means is, which means it will tell me the length around it. Like, say this square rectangle is 2 and 1. You would have to have 1 on the two sides and 2 on the top and bottom, or else if it was 1 with height, the other and 2 with length, then it would not fit in the card, since the card would have to be with a perimeter of what you see right here. So, next explanation, I guess. Okay, another answer you could have said is, the perimeter of an envelope that would fit Sydney's card would be a little more than 28 inches, in parentheses, 5 1/2 plus 5 1/2 plus 8 1/2 plus 8 1/2. Another possible envelope with a perimeter of 20 inches would be 2 inches high and 12 inches long. 2 plus 2 plus 12 plus 12. The card would not fit in that envelope. If you do not understand that, it would have to look like, the card would have to look like, if it looked like, this, and this, it would not fit, but if it was, 5 1/2 inches, and 8 1/2 inches like that, it would be that, because, well, the card has to be the same exact perimeter layout as the envelope, or else it would not fit, because, like, say this is the envelope and this is the card. This will not fit in here, even though they equal the same thing. They are not the same thing, because they have been added together differently. So, next explanation. The last explanation you possibly could have used is, knowing the perimeter of an envelope can only help Sydney determine whether or not the card will fit if the perimeter is less than the perimeter of the card. If the envelope's perimeter is smaller, the card will not fit. What that means is, like, it will only help you determine the perimeter if it will not fit. Say, this is the card, and then this is the envelope. It will not fit, so you cannot fit this and there, but it will not determine help determine it if the card is bigger, though. Oh wait, no, it is bigger anyways. It will not help it determine it if if the card is smaller than the envelope, because you can just not do that in math unless you have a card and an envelope that you can fit in each other. And most of the time you do not. So it will only help you determine if this is bigger than it, but not smaller than the envelope. If you got anything close to these explanations, you're good. But if you don't, just write one down in your math book. And now, moving on, we are going to do a new practice problem and then the lesson pages.
Alright, here's a practice problem for you. So here's a line plot. Write it down in your notebook. Put 1 and 1/4, 1 and 1/8, 2 and a half, 2 and 2/8, and 1 and 3/4 on the line plot below. Write this down in your notebook. Put all these fractions on the line plot. And unpause. But first, pause, of course. Okay, here are the answers. Let's first do the eighths first, and then we're going to go on to the fourths and halves, because the eighths are the kind of the hardest ones. So when you have the eighths, each line here to 2 inches is 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Oh, actually, if you don't count that one, the starting point, if you don't count that starting point, then after that it's all eighths. And each of those lines is 1/8. 1/8? Okay, so let me mark it. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, or 1. So that's when you finish the eighths. So if you did 1 and 1/8, here's the 1, the starting point, and then 1/8 would be right next to it. And always remember that the lines are just where the fraction stops, because the middle is where you actually count, but the lines are just where you put the x's. Because if you put it in the middle, it became kind of confusing. So then if you did, so we'll mark that off in red. So if you did 1 and 2 and 2/8, it would be 2 here, and then 2/8, 1, 2. Not counting that starting point. I'm going to mark that in red. 1, 2. And then we're done with that one. And then we're going to move on to fourths. Oh, I'm in eraser mode. So we're going to move on to fourths. So 1 and 1/4. So 2/4.
What's that?
Okay, so when you do 2/4, it's usually here. You don't necessarily always skip a line, but they're usually over here in the middle, between 1 and 1.5 in this case. And 2/4 or 1 and 2/4. If you do this without divided by 2, 2 divided by 2 is 1. 2 divided by 4 is half, 2. And then you add that 1. You don't divide the 1 by 2, because you can't do that. So then you're going to have 1.5. And then the next one, so this is just 1 and 1/4, but if it was 1 and 1/2, then from 1 and 1/4 would go over here, because if you divide, then you will get 1 and 1/2. So now we're going to do 1 and 3/4. So I'm going to use green. 1 and 3/4. So this is 1.5, and then you go to this next X here, and that's in the middle of 1.5 and 2. And now mark that off. Last is 2.5. And 2.5 also is, well, you can just look right here because it's already marked. So then you just put an X there. So this is supposed to be your answer. So that is what you were supposed to get. Oh, and also, one thing for the future, 2 eighths also equal 2 divided by 2 is 1. 2 divided by 8 is 4 equals 1/4. And then 2 4 divided by 2 would be 1.5. So that's actually a pretty easy way to do all of these. Right. So that's it for the practice problem. Now, and now I just mark this. Okay, so now let's move on to do pages 286 and 287 in your math journal. Pause to answer the questions in your math journal, and then unpause to go check the answers. Alright, here are the answers. So I'm going to do the first page right here, and then Ethan will do the next page. So this is the title, Sample Answers, Envelope Heights. So you're supposed to list all of these height and lengths into this line plot. And then this is the title, and then the label is Sample Answer Height in Inches. And just check out this line plot over here, and make sure all the X's are in the right spot. And then I'm going to do this part. Okay, so for the first answer is, first question is, what is the largest envelope height sold? 6 inches. As you can see with the X's and the line plot, it goes all the way to 6. So, where's the smallest envelope height sold? 3.5. So when you're doing this, the smallest envelope's height sold, the one with an X on it. If it was 3, it doesn't have an X on it, so it wasn't sold. So it's 3.5. Which envelope height is staffed by the most by the right staff? 3 5/8 inches, because it has the most X's here. And what is the difference between the largest and smallest heights? 2.5 inches. So the smallest height is, okay, so 6 minus 3.5. So let me just, 6 minus 3.5. So we'll have to turn this into 2 halves, and the 6 into a 5. So then you get 1/2. So then you get, not 3, because we're going to 5. 2.5. So that's how the answer is that. Because you're looking at 6 and 3.5 and mix them. And then in the United States, the most popular business envelope is 4 1/8 by 9 1/2, which it is called the standard number 10 envelope. How many of the envelopes sold at the right stuff have a height larger than 4 1/8 inches? Right, so 4 1/8. So this is 4 1/8, and then after that, I'm going to make a line for 4.5, and then you count the numbers over here on the side of the red line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how it's 10 envelopes. And then, how many envelopes have a height smaller than 4 1/8? Then we're going to look at not this side of the red line, but this side. But we're cutting off the 1/8, so it's not in there. So the 1/8 should be in the middle. Alright, and then you're going to have 1, 2, 3, 4, 5, 6, 7, 8. So that's how you get 8 envelopes. Now, how much smaller is the height of the number 10 envelope than the smallest one sold? Alright, and the last, and the answer is 5/8 inches. And then the last question is, how much smaller is the height of the number 10 envelope than the largest one sold? The answer is 1 7/8 inches.